Welcome to Math 31. This is a review lesson on domain and range. So we start by looking at a few things you're probably familiar with already. And that is, first, the domain is the set of all first coordinates in a set of ordered pairs, usually x. It doesn't have to be. It's possible that it could be in some application where it's time or anything that's on the horizontal axis. But for our purposes, it'll be x almost always. And then the range, accordingly, is the set of all second coordinates in a set of ordered pairs, usually y, the y variable. And for simple questions, you get stuff like this. Determine the domain and range of this given function. So the domain, we just take a look and take the x coordinates out. And they would be 2, 3, and 4. Simple as that. The range would be y. Just note how I'm indicating it. You can go y equal or just like that. It would be 4, 6, 8. Now, that's not usually the way these things are expressed, of course. You're more likely to have a graph or eventually an equation. Now, the graph's fairly straightforward to take the information. So if we took a look at this first one, so getting the domain and range of the following, this graph like this, we can by inspection identify both domain and range. And this is a quadratic type graph. It's not a function because it's opening to the right. But it doesn't really matter. We can see that the smallest x value of this one is 0, and that we go all the way to the right. So we could indicate that by going x is greater than or equal to 0, and that x is all the real numbers greater than or equal to 0. And I'm going to use interval notation for this one. So I have a closed interval at 0, and then it goes upwards forever, like that. So that would be the domain. The range, we can tell by inspection that this is eventually going upwards forever and then going downwards forever. So it does in fact cover all values. So y would be an element of the set of real numbers or a member of the set of real numbers and can be then in interval notation be expressed like that. Let's take a look at another one. Remember, you can always pause this at any point if you need to go through it, or if you've got the handout, which you should have printed off, feel free to do the question first and then check the answer. Now, with this ellipse, the domain has a lower limit of -4 and an upper limit of +4. I'm going to go straight to interval notation for this. So the domain will be x, with a bracket, lower limit of -4 inclusive, upper limit of +4 also inclusive. The range, same idea. -3 as the lower limit, +3 as the upper limit, inclusive. Next question takes a reciprocal function, and this is an example where set notation is much easier, because all values of x are permissible with the exception of x equals 0. So easiest just to write it like this. X cannot be equal to 0, but otherwise all real numbers. If you were required to use interval notation, you would have to break it into two sets. And note that this negative infinity is the limit on the left to 0 non-inclusive in union with all the numbers that are 0 or higher. Again, non-inclusive, so open intervals for both of them. So it's not quite as convenient as is set notation. The range, similar thing. I'll go directly to interval notation because it covers all real numbers with the exception of 0. So negative infinity to 0 in union with 0 upwards to positive infinity. This one changes gears a little bit. We're given a rational function. That is, we have a polynomial on top and a polynomial on the bottom. And you're going to note right away that the restrictions on x are going to give you the domain. So restrictions on x, the denominator x plus 5 cannot be equal to 0. So x cannot be equal to negative 5. Now, the important thing to remember is that you have to indicate these restrictions before you simplify. Because what will happen when you factor that numerator is that you get in this position, x minus 4 times x plus 5 divided by x plus 5, and then if we divide out these two common factors of x plus 5, we are left with y is equal to x minus 4, which is linear. So that's just a regular line. Now, as we'll see later on, that it's a regular line, but there is something significant about that restriction. But I'm going to go onward now to get the range. Now, the difficulty with the range is that you have to make sure you substitute the inadmissible x value into the simplified expression. And this would become obvious if you did attempt to plug it into this original. If you did substitute x equal negative 5 into the original, you'll end up with 0 over 0. Try it. And that doesn't give you any information. So it has to be into the simplified version to get the corresponding y value, which matters because we need it for the range. So we go into y is equal to x minus 4. We replace x with negative 5, and we get y is equal to negative 9. And then we've got it. And this tells us that the range is y is not equal to negative 9 YER. Now, in interval notation, of course, this would be broken into these two sets, negative infinity to negative 9 in union with negative 9 to positive infinity. And then we're okay. So that's what you have to make sure you do. And take that back there if you like. And then let's finish off the domain, because we didn't really clean it up too well. And I'll do that on the next graph. The domain would be negative infinity to negative 5 in union with negative 5 all the way to positive infinity. And we call that hole in the graph a point of discontinuity. So it's a linear graph, y is equal to x minus 4, pretty routine looking, except there's a hole in the graph. Now I'm not going to concentrate much on the calculator yet, but if you did graph this on your graphing calculator, it would look like a regular graph. You wouldn't see the hole, but if you did go through your table, you would note that it is undefined, or there's an error where x equals negative 5 is supposed to be. So you really can't use your calculator to get the information for this. You have to do it algebraically. Now that's going to be the end of this one. The next lesson is going to be on domain and range, but the algebraic calculations, which I think will force you to think a little bit harder. Thank you for your time.